Hey guys, welcome to the final video in chapter 5. So we're going to wrap up chapter 5. We're talking about exceptions to the octet rule. So of course, like everything in chemistry, we give you all the easy stuff first and then we throw kind of a curveball at you. But if you've been practicing this material, the introduction of this shouldn't be too difficult because you've actually already practiced the skills that you'll need for this. Okay. So exceptions to the octet rule. There's actually 3 exceptions to the octet rule. You will only be tested on one of them, but I'm going to tell you about the other ones because they do exist, so I want you to know about them. So the first exception to the octet rule is something called a free radical. So a free radical is when we have an odd electron species. So you add up all the electrons that were brought to the party and it ends up being an odd number. And as I said before, they do exist. We just are not going to deal with them in this class. So this is what a free radical might look like. You've probably heard of free radicals from a biological standpoint. So if you eat antioxidants, it will neutralize free radicals in the body. When these electrons are by themselves, they're very, very unstable and very, very reactive. So they will react with things inside of your biological system and could harm different cells, cause mutations, things like that. Antioxidants are very good at seeking out these free radicals and neutralizing them. So that's where you probably heard of free radicals before, and this is what they mean in a chemistry sense. The other is an incomplete octet. So we've talked about hydrogen as being an incomplete octet. There are other atoms that are okay with having 2 or 4 or 6 electrons. And most of these happen to be centered right around helium as well. So incomplete octets are okay with having less than 8 electrons. The one that we are going to focus most of our time, attention, and points on is going to be expanded octets. So expanded octets are going to have the ability to take on more than 8 electrons, more than 8 valence electrons. Okay. So the first thing we need to know is who is capable of having an expanded octet. So anybody that is in the 3rd energy level or a higher energy level, so 3rd energy level, 4th energy level, 5th energy level, so on, can have an expanded octet. If you're looking at your periodic table, you'll notice that it would be the 3rd energy level or anything below it from a physical standpoint, physically below it on the periodic table. So any of those atoms can have an expanded octet. So what's important about the 3rd energy level? Why is that all of a sudden a good spot? Well, remember the 3rd energy levels where that D block becomes available. So we've got a little bit of extra space to shove some extra electrons in that D block or rearrange some electrons around so that it can handle more than 8 valence. So that D block makes these atoms do kind of some funny things, and this is one of those funny things. So expanded octets, 3rd energy level or higher. Okay. With this expanded octet, actually one quick thing I want to talk about here. Expanded octets, so we don't just get to add as many electrons as we want. So if we don't have 8 valence electrons, we can either have 10 or 12. So those are going to be the 2 expanded octets that we talk about, is a 10 electron expanded octet or 12 electron expanded octet. And when we're talking about expanded octets, we're only talking about the central atom. So we're not going to expand the octets for anybody else, for any of these terminal atoms, just the central. Okay. With the expanded octets, we're now going to have some new 3-dimensional species, new 3-dimensional pictures to talk about. So here we see phosphorus. This phosphorus has 5 chlorines around it. So if we look at how many electrons this phosphorus has, he has 2, 4, 6, 8, and 10 electrons. So this is going to give us a new geometry. So having 5 electron groups is going to be something called trigonal bipyramidal. So we're going to have kind of this triangle here in the middle with the 3 chlorines around the central atom, and then a pyramid going up towards the top and a pyramid coming down towards the bottom. So bipyramidal means there's 2 pyramids, and trigonal, it's a triangle-based pyramid. So trigonal bipyramidal. Okay, so that's our new electron species. Just like with the other ones, we could have 5 electron groups. We could also have central atoms that has lone pairs as well. So we're going to get some interesting shapes with that. When we have these expanded octets, the lone pairs are going to go in a specific place. So we need to talk about where these atoms are so we can talk about where the electrons are going to go. So these atoms here along this central plane here are called equatorial. So think about looking at a globe, and where's the equator? It's right there in the center of that globe in a flat plane. So these are equatorial. And then the axial positions are going to be the ones going up to the top and ones coming down to the bottom. So this globe spins on its axis, these axial chlorines here. Okay. When we have in a 5 electron group, our lone pairs are going to go equatorial. They are not going to go axial. So if you look back at this slide, you'll see that the bond angle between the 3 in the middle is 120 degrees, and the bond angle between the axial and this one is 90 degrees. And if you remember too, lone pairs are these big fat things, right? They take up more space. So there's more room putting them equatorial than putting them axial. So they go equatorial. Okay. So having one lone pair in that equatorial position, we've still got this trigonal bipyramidal. But again, if I put a box over this lone pair, I hide it. We get this interesting little guy here. The molecular geometry would be seesaw. So turn this on the side and you see a seesaw going back and forth. If we've got 2 lone pairs, so 2 lone pairs are still going to go on that equatorial. So 2 lone pairs equatorial, 1 atom equatorial. Hide the lone pairs, we're going to get a T shape. And then if we have 3, I don't have a picture of it. If we have 3 lone pairs, so if we picture this guy right here as a lone pair, so a 3rd lone pair right here, and then I hide all those lone pairs, what you would see is linear, so a straight line. And of course, there's a chart that has all of this. That's why I'm kind of going through it fast. All right, so we can also have an expanded octet that has 6 electron groups or 12 valence electrons. So 6 electron groups is going to give us an octahedral shape. So this is still kind of like that pyramid. So pyramid going up, pyramid going down. But in this case, the pyramid has a square base. Where do we get this prefix? Octa, there's actually 8 faces on this shape. Okay, so here's our octahedral geometry. Same thing here. We've got our equatorial positions. We've got our axial positions. And when it comes to 6 electron groups, the lone pairs are going to go axial in this case. So everything's a 90-degree angle, and there's a little bit more room on the top and the bottom. So that's where they go. So if we have 1 lone pair, that would give us a square pyramidal, so a square base pyramid. And this is a picture of 2 lone pairs. So those lone pairs are going to go axial, and if I hide them, The molecular geometry is square planar, so this would be a flat square. Okay. So I know I flew through those electron geometries, but if you've practiced this material, you know that there's a chart coming, right? You don't have to memorize this information. So here was the first half of the table that I gave you in a previous slideshow. If you've looked it up in your textbook, you'll see that there is a whole nother half to this table. And all of this is our expanded octets. So when you guys look at the helpful handouts and print out the sheet, it'll have an 8x11 sheet with this whole table as one big thing. It just doesn't fit on the slides like that. So this is one big sheet. You use it the same way that you use it for the other ones, but just know that expanded octets exist. Be able to use the table and tell me molecular geometry, electron geometry. So that wraps up all of the information for chapter 5. That is a lot of information. Your job now is to go out and find every practice worksheet, website, Quizlet, whatever that you can find, and just keep practicing this material. Okay? I hope you guys found this helpful. Happy studying.